Hello and welcome to the Daily Space. For today, I think it's June 25th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. And I'm actually checking the date because I hate lying to you about the date. These are things I should know. It's the 24th. I totally lied to you. Hello and welcome to the Daily Space for today, June 24th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Now, if today's setup looks a little bit, well, like what we used a long time ago before we had green screens, that's because I have a whole bunch of equipment packed up to take with me to Joshua Tree National Park, where I'm going to be later this week with some of you. I will be there for the All-Stars Star Party along with Skylius, Fraser Kane, John Michael Gauthier, and of course the organizer, Paul Matt Sutter. And well, I'm going to be taking everything I can possibly take on that airplane. And so you're getting the weird background and poor lighting. But one thing you're not going to get is poor science. We have an amazing lineup for you today. And let's see if I can get this started. Now, I would like to start by saying this object is not actually a poorly drawn clown, which unfortunately is all I see when I look at this image. So I simply needed to, well, share my brainworm with you. No, this is not a poorly drawn clown. What this actually is the light from an extremely distant galaxy that has been bent by that central bright cluster. And that bent light is coming to us with 4 different versions of the galaxy, twisted around and coming back to let us effectively study the, well, halo of gas around the central nucleus of an object that, well, its light started traveling to us in the first billion years of our universe. So, yeah, this image was obtained by the Muse instrument on the Very Large Telescope down in Chile. And it demonstrates that we now have the capacity to measure details from the ground that we once thought we could only see from outer space. This weird arc lets us study how galaxies were evolving in the earliest parts of our universe's history. In the press release for this object, the press release came to us from the European Astronomical Society, where these results are getting presented at a conference this week. The press release doesn't exactly tell us how far away that distant galaxy is located, but it does state this is, as I said, light from the first billion years of our universe. This is a new instrument. It's showing off what it's capable of doing. And I, for one, am really looking forward to seeing the publication that comes out of these results. And this image that isn't a clown, this image allows us to study things we never thought we'd be able to study. And speaking of studying things we never thought we'd be able to study, this is a slice through a rock from Mars. Over the weekend, I learned something I hadn't previously known. Something that kind of changed my view on most of my jewelry box. It turns out that if you wait long enough, a diamond is just going to revert back to graphite, the stuff that makes up pencil lead. But a zircon is going to sit there being hard and holding on to its gassy inclusions for forever, basically. And this means that when we get meteorites on Earth that contain zircons, we can, with a great deal of difficulty, get samples of the gases that were surrounding where the zircons formed when the zircons formed. In tearing apart 2 samples, the one that you see here and the significantly shinier sample, scientists at Western University in Canada were able to figure out that these crystals are from 4.4 billion years ago. They contain gases from 4.4 billion years ago. And what's kind of amazing is when we study rocks like this here on the planet Earth, the rocks show that there's massive amounts of impacting still going on. But when we look at these rocks from Mars, they don't have these same signs. This hints that our world's era of heavy bombardment may have lasted longer than the same period on Mars. This also means that life may have had the potential ability to begin to thrive on Mars earlier than previously thought. Now, we don't know for certain if Mars did or did not, or does not have life, but this does segue nicely into my next story. Over the weekend, the New York Times carried a story where a whole bunch of super excited scientists couldn't keep their mouths shut about how Mars is belching methane. Last week, in an unexpected surge of gassiness, the air around the Mars Curiosity rover surged to a record-breaking, wild 21 parts per billion, which doesn't sound like a lot, but it is. Like in the past, 7 parts per billion was something we got excited about, and this was 3 times more methane. While methane has previously been detected on Mars, this surge is crazy. And it's the kind of craziness that, according to the team of scientists who were all speaking on their own, NASA hadn't put out any communications about this. It was so exciting that the mission team changed up what they were planning for the rover to do over the weekend so that they could take follow-up measurements. It also turns out that the same day these measurements were made, Mars Curiosity, which is located in Gale Crater, had pass over its head Mars Express, which has instruments on board that have the capacity to detect methane if it's mixed in well enough. And so Dr. Marco Grana from Mars Express, he's hoping to have results later this week of what Mars Express was able to see at the same time. And there's a chance that we might even start to get news about this weekend's measurements later today. Now, I kind of suspect the scientists are going to get told to keep their mouths shut, and there will be a big press release if anything cool was noticed. But I'm hoping for leaks. Now, if the idea of methane on Mars making it into the New York Times sounds weird, let me explain. Methane is a molecule, CH4. It's a carbon and 4 hydrogens. And this particular molecule breaks down in sunlight. This means that any methane that is detected in its atmosphere has to be new. And methane doesn't come from a lot of different places. The primary mechanisms for making methane are life. Yes, I said life, and the much more boring possibility of geologic processes. Now, any methane that's created can also get trapped in ice, and when that ice melts, the methane gets released into the atmosphere. This is something that's currently going on as the Earth's permafrost is beginning to melt. Now, looking at Mars and making this particular observation, there are 3 possibilities for where the methane came from that are exciting and one that's super boring. The 3 exciting possibilities are, well, it could be that Mars is still geologically active, which isn't something we thought was true. It could be there's life on Mars, and how awesome would that be? Less exciting, it's also possible that there was life on Mars, and the methane it created got trapped in ice, and that ice just melted. Now, in the boring, but as far as we know, most realistic possibility, methane from past geologic activity got trapped in ice, that ice melted, and that geologically produced methane got released. Now, when I say that that statistically may be most likely. I say may because honestly, we have no idea how common life might be on other worlds. It could be that life is so common that every time we see a world with methane in its atmosphere, we need to think life. I mean, for all we know, Titan has life, Mars has life, and all these sources of methane are pointing to life. We don't know. It's probably geologic activity. Probably. But we have no idea. And that's awesome. Now, in 2020, the United States and the European Union are both going to be launching rovers to go to the Red Planet. And both of these systems have the potential capacity to carry this work to the next level, to start looking for the signatures of past life. And maybe for present life, I just don't think they can talk about building that into the spacecraft. So here's to hoping we can figure out what this is in our lifetimes. And for now, here's to hoping for more excited scientists leaking stories to the New York Times. And that's all I've got for today. So now I am going to take your questions. And while you type them in, I'm going to remind you to go ahead and @ me in the chat, CosmoQuest X. That will make it much easier for me to find your questions. And while you type them in, I'm going to remind you that this is a production of the Planetary Science Institute, working in collaboration with Youngstown State University. We are a 501c3 nonprofit dedicated to exploring our solar system and beyond. When you donate to us, your donations are tax deductible where the law allows. And starting, I think it was last week, we have started sending out my show note / script that I never quite follow as a email every day to the folks who support us over on Patreon. So if you want to get in your inbox a transcript of today's stories, follow us on patreon.com/CosmoQuestX. Now, I know a lot of you can't support us financially. I can't support everything I want to support right now. Times are tough. But there's a lot of other ways that you can help out. I help out by fostering a dog that you can't see because she's off camera. That's how I help the organizations that matter to me. If you want to help the organizations that matter to you, and we're one of them, well, you don't have to adopt me. But you can help spread the word that we're here and we're your place to learn and do science. So help recruit your friends, your enemies, your coworkers, your collaborators to come and join us at CosmoQuest X, well, wherever social media is found, and on the web at cosmoquest.org. Today is Asteroid Day, and we do have the capacity for you to help us map out an asteroid. So if you want to be part of, celebrating Asteroid Day with some asteroid science, here is your opportunity. Click on over to benu.cosmoquest.org and help us make sure that OSIRIS-REx finds the right place to grab a soil sample. If everyone who's participated so far does 15 more images, we'll be done. Now, I know most people won't do that. So if you are on the site, maybe do a few extras for those people, maybe find new people to replace those people. We can do this, but only with your help. Okay, so back to your questions. Here is me scrolling up through the chat. Whoa, and scrolling beyond the chat and wondering why Binary Ablaze was doing evil laughter in the chat. Okay. Yes, Bill Nash is going to be at Joshua Tree with us. I'm really hoping he can help me become a better photographer. He's amazing. I am not. A zircon is forever. That is true, Binary Ablaze. It really, really is. So Astrowise asks, regarding the gravitationally lensed galaxy, is it possible to take the round bits of the circle we see and determine what it looked like originally? Yes, sort of. It's sort of like trying to recreate what you see in a funhouse mirror without being able to actually measure what the details in the mirror are. There's a chance that you could take someone like Peter Dinklage and turn him into a basketball player if you don't know the shape accurately, but you'll still be able to get the right sense of the features. So we are able to a certain degree, deconvolve. That's the fancy scientific term, deconvolve. We're able to sort out the stretched out images and work backwards to figure out more or less, based on assumptions, what the galaxies looked like, but our assumptions might add deformities, and we just don't have the ability right now to fully know. So yes, sort of. Okay, let's see. Yeah, I agree with you, Veronica. I would totally wear those Zircons. They're amazing. I wish the crystals weren't microscopic, because what I really want is a window made out of that stuff. Let's see what else we have in here. Lag Adder added cheese to the chat. I don't know why that thrills me so much, but it does. Okay. Scrolling for questions. Thank you for the bits, R Instro. I don't have a dog cam, so you're just going to have to accept my excitedness as thanks. Thank you. Okay, let's see. So Fenring asks, methane chlorates maybe, but what made it in the first place? Yes, methane chlorates, rocks, minerals, ices that have trapped inside the matrix of the mineral methane. That's possible. But that does raise the question of where did the methane come originally? And we're back to life or geology. And again, that's awesome. Well, geology is kind of boring. But in this case, not in general, just as an explanation for methane, it's kind of boring. Nebula Cluster also gave bits. Thank you so much. I have a dog sitting beside me that I feel a desire to pick up, but she's chewing a bone in quiet, so I'm not going to. So Binary Blaze says, we're going to raid deep astronomy. Okay, that works. Planetary Pan says, did you hear about the fireball over Queensland, Australia this weekend? No, I didn't. I'll have to look that up for tomorrow's episode. I was at a meeting all weekend and I just didn't keep up with things. So much going on. It's okay, Binary Blaze. It's okay. Let's see what else. We have more bits from AstroWise or AstroYYZ, however you want to put it. I think both are apropos. Thank you. Inflict science on others. Yes, we shall. And as Binary Blaze says, we are going to party hard when we are halfway done. Let me see where we are right now. So I'm going to benu.cosmoquest.org, and we are sitting at 2,691 images remaining. Oh man, guys, you need to do more science, please. All right. And we have a Pokemon. I was playing Pokemon earlier. Thank you, Paranor. Speaking of painting worlds, there's a good chance I will be desperately doing artworky things later today. Not sure yet, because I have many things I need to desperately get done while packing. But yes. So Rukato Presents asks, would a comet containing methane hitting Mars cause the methane spike? It could have, but we didn't see that. And there's so many orbiting spacecraft around Mars that would have been seen. You can't just sneak a methane comet to Mars. I will have a beer at Joshua Tree. So yeah, that is all I've got for today, and I'm not seeing other questions. So thank you for joining me, and if Deep Astronomy is currently streaming, I'm not going to linger here. I'm going to kick you guys over to him so you guys can see what goes on at NASA Social and maybe consider joining later. Now, I am going to, as we always do, very awkwardly find and try and roll the credits. Oh, screen, why won't you load? So Streamlabs did some upgrades over the weekend, and they're very determined to ask me questions about things I can't do on my computer because I don't have a PC. I love Streamlabs, but they keep offering me things, but not offering them for Mac. Anyways, I am now going to roll the credits, raid Deep Astronomy. But before I do that, one last reminder. You should go outside and look up. Jupiter is low on the horizon right now. It's a beautiful time of year here in the Northern Hemisphere. Your results may vary in the Southern Hemisphere. But wherever you are in the world, have a fabulous morning, evening, afternoon, and I will see some of you later this week. Bye-bye.